absolute value inequality. Now think about absolute value as distant from 0. Absolute value of x equals 3, so x is equal to either -3 or 3, right? So we have this two, this one or this one. So where are those x? Think about this as a distance from 0. So absolute value of x is a distance from x to 0, from the number to 0, okay? And over here it says that this is the tip point to this absolute value. So we will say that is less than, and over here we have this 3, so it is 3 units. So what are those numbers? That the distance from 0 is less than 3 units. Okay, let's think about this. Think about this as your home right here. So 0 over here is your home, it's your base, and now you want it to be the distance from home is less than 3 units. So you start traveling. Okay, for example, you say, oh, I don't want to go too far away for work. I wanted my workplace to be within 3 miles from my home. So so from your home, you're going to go to the right. Okay, now all those numbers over here, the absolute value over here is going to be less than, okay, so you're going to travel, right? So it's going to be less than 3 units, right? Still less than 3 units. Tell me, where should I stop? When I get to here, this is exactly 3 units, right? So should I include this one? Should I include this one over here? No. So I should stop over here. Okay, if I go to the right, all those are within 3 units away from 0. Once I get to this is 3 units, exactly 3 units away from 0. So I should stop right here. So I will not include this n. So I use a parenthesis. Okay, so it's like having this open circle right here. All right, I can also move to the left side. So within 3 units. So move until I get to this point. So when I get to this one, that's exactly 3 units. So I will not include that. So what's happening over here is, if you want the absolute value of x is less than 3, then x could be any number from here to here, any number. So you want it to be the distance from 0 is less than 3 units, then x could be here, could be here, could be here, could be here, any number. Okay. Now, some of you would like to plug in some numbers just to get a feel of how it works, right? So let's try to pick a number here. I can pick, say, 2.9. The absolute value of 2.9 is 2.9, so that's less than 3. I can pick a number over here, say negative 2.99. The absolute value of that is 2.99, so that's less than 3. And also any other number here. Could be 0, could be 1, could be 2, could be 1/2, etc. Okay, so x will be any number from -3 to 3. So here is -3, here is 3. So x is any number in between. So x greater than -3 and less than 3. So this absolute value inequality is going to have this equivalent double inequality. So x here will be between -3 and 3. So you first locate -3 and 3, and you say, if I want this absolute value less than 3, then it's going to be between these two numbers, between -3 and 3. Okay, now the next one here. This time it has an equal sign, less than or equal to 3. So it will be similar, right? So we first locate this -3 and 3. If I want the absolute value of that is less than or equal to 3, so that will be the inside, right? That will be the inside over here. So it will be the inside over here. Okay. Should I include the endpoint, the 3 and -3? Yes. So because the equal sign there, so equal to 3 or -3 are included. So the endpoint are included. So x will be any number that is between -3 and 3 and including the endpoint. So you will locate -3 and 3. X will be between, but there's an equal sign. So that has equal sign over here also. Okay, now we're going to solve this absolute value inequality. So that is less than 9. Okay, think about what are the two numbers. See the number 9 right here, 0. So the two number over here you locate will be 9 and -9. So think about this absolute value over here as a package. So this package over here is going to be anything that is going to be between, okay, so we have this 9 and negative 9 and 9, right? So this 2x minus 3 is going to be any number will represent any number between negative 9 and 9, between these two. So we'll have this 2x minus 3 greater than what? Greater than
Negative 9.
negative 9. Yeah, we got it. So greater than negative 9 and less than 9. So in between. Now to solve this, then we will add 3 to all sides. So we'll have we have 2x that is greater than negative 6, less than 12. And now what?
Divide by 2.
Divide by 2. We got it. Okay, divide by 2. So we'll have x greater than negative 3, less than 6, and less than 6. So now if we indicate this solutions are in interval notation, so what will be that interval? Parenthesis, negative 3, comma 6. Okay, so that will be this interval. And if I want to write that in a subfield notation, so that would be this, a pair of curly braces. Okay, the variable here is x, and then put a bar here for such that x here is greater than negative 3 and less than 6. Got it? Okay. Now let's try the second one that is kind of similar, but the second one over here. So first think about the number 9 over here. Right here, so here it is the 5 right here, 5, right? So on the number 9, you first locate negative 5 and also 5. So think about this whole thing inside here as a package. So think here inside as a package. So this negative 5x plus 10, this package right here, this whole expression here, will be, how is it related to negative 5 and 5? If you want the absolute value of that less than or equal to 5, then that is going to locate it within negative 5 and 5, right? Okay, so it should be anything within this, including the endpoint, right? Including this endpoint right here. So what can we say about this negative 5x plus 10? So it's going to be between greater equal to what? Less than or equal to what?
Negative 5.
Negative 5 right here and less than or equal to 5. Right? So it's going to be in between these two numbers. Now to solve this, we're going to subtract 10 on both sides, on all sides. So we have negative 15 less than or equal to negative 5x less than or equal to negative 5. Now what?
Divide by 5.
Divide by
Negative 5.
negative 5. Yes, divide by negative 5. Divide by negative 5. Now remember, this is the action step. We divide by negative 5. So we need to erase this inequality sign and switch right there. Okay, so that will be this, go the other way. So switch, so divide by negative 5, we need to switch inequality sign.
How come we didn't switch it on the last one?
Okay, how come we don't? Now over here we divide by this negative number, right? So that's why we switch.
Oh.
What about the last one? The last one over here, we divide by positive 2. So no switch. Okay. So only when you divide by the same negative quantity, then we switch the inequality sign. Right? Okay. Now we get to this. So we have 3 here. Okay. And greater equal to x, greater equal to 1. This is correct. However, it's not the it's look a little bit awkward because we normally wanted to have from small to big. Okay, so a better way to write this is this way. These two are equivalent because as long as the tip point is the same thing. You see, this is, you read this as x is greater than or equal to 1, right? So over here you also have x is greater than or equal to 1. It's the same thing. As long as you keep the tip point to the same quantity, then that inequality will be equivalent to the one that you solved, right? Okay. So these two are equivalent. So if you write it in interval notation, so that will be bracket 1, comma 3. And if you write it in set notation, so that will be a pair of curly braces. The variable here is x, such that x is greater or equal to 1, less than or equal to 3. You got it? Okay. Are you guys ready to move on? Give me a thumbs up if you guys are ready.
Mhm.